Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from power system stability, and the name of the topic is swing equation of a multi-machine system. Now there are two parts. First one is two coherent machines. Now we know the multi-machine system consists of a number of generators with different ratings which are interconnected with each other in a parallel. So I will draw the diagram. This is your, let's say, first generator. This is your second generator. So I will take this as generator G1. This will be generator G2, which is connected in the parallel. This will be a one bus part. Let's say the load angle of generator G1 is delta 1. Load angle of generator G2 is delta 2. Then angular momentum of machine 1 is M1. Angular momentum of machine 2 is M2. So I can represent this as a single equivalent generator G, and here angular momentum or moment of inertia will be M equivalent. Now what is the swing equation? We know that the formula of swing equation. So swing equation for machine 1. I will write a swing equation for machine 1. What it will be? It is M1 d square delta 1 upon dt square will be equal to what? Will be equal to Pm1 minus Pe. Take this as a equation number 1. Now can I write a swing equation? So I will write a swing equation for machine 2. Now what is the change? Nothing else. All the parameters are same. Just we have to write it as suffix. We have to change the suffix. M2 d square delta 2 upon dt square will be equal to Pm2 minus Pe2. Treat this as your equation number 2. Now, if the machines are swinging coherently, here we are discussing about two machines which are swinging coherently. Then what is the case? Swinging coherently means what? Here the load angle delta of machine 1, load angle delta of machine 2 will be same. So as it is the same, we will treat this as a delta. Now what I will do, I will add equation number 1 and 2. So do the addition of equation number 1 and 2. If we add left hand side and right hand side, now in place of this delta 1 I can write delta, in place of this delta 2 I can write delta. So therefore from both the equations, from left hand side I can take a common d square delta upon dt square. What is the term here? It will be M1 plus M2, which is equal to, now I will add like this, Pm1 minus Pe1, right hand side of equation number 1, plus Pm2 minus Pe2, right hand side of equation number 2. Now what I will do, I will collect these two terms like this, Pm1 plus Pm2. I will collect all the mechanical power terms, and here if you see, here if I take a minus common, then what it will be? Plus, here you will see, plus Pe1 plus Pe2. Okay, sorry, there is a mistake, not a plus. I will take minus common here. So you will get minus of Pe1 plus Pe2. So this Pm1 plus Pm2, it is called as Pm equivalent. And this term Pe1 plus Pe2, it is called as Pe equivalent. This term M1 plus M2, it is called as M equivalent. Now how I can write this expression? Yes, I can modify it. I can modify it like this. M equivalent. So what it will be? M equivalent equal to what? M1 plus M2. Now you know what is the formula of M1. M equal to what? GH upon pi F. Already we have gone through a previous video. So G1 H1 upon pi F plus G2 H2 upon pi F. And here also you can write G equivalent into H equivalent upon pi F. So how you can write a formula for H equivalent? Again, this formula is important. Based on that we will solve few numericals. H equivalent will be equal to what? G1 into H1 plus G2 into H2. Now this pi f from both sides will be cancelled. So I can write it at this as a G equivalent. This is the formula of swing equation of multi-machine system, or you can say two machine system. This G equivalent, in some books it is represented as GB also, that is a common base MVA of the new system. Now we will discuss what happens when the two machines will be swinging non-coherently. So part B is nothing but two machines swinging non-coherently. Please remember, when we discuss about non-coherent, then the meaning is nothing but delta 1 and delta 2 will not be same, it will be opposite. So let us consider, there is again one generator. This will be generator G1 having angular momentum M1, then load angle is delta 1, then this is transmission line point, and here this will be the other generator G2 having this moment of inertia M2 or angular momentum M2, and here the load angle will be equal to delta 2. So again, can I write the same way? Can I write equation, swing equation for generator G1? What is that? It will be your M1 into d square delta 1 upon dt square will be equal to what? PM1 minus PE1. So this is your equation number 1. This is your swing equation of generator G1. Similarly, we can write M2 d square delta 2 upon dt square will be equal to PM2 minus PE2. Treat this as a equation number 2. Now what we will consider here, we will consider that delta 1 is greater than delta 2. So how I can write a net delta? Can I write like this? If I shift this delta 2 towards this side, I can write it as delta 1 minus delta 2. Please remember the basic law of a power system. Basic of power flow equation is real power flows from higher rotor angle to the lower rotor angle. That is, the power will flow from the load angle delta, whose load angle value is more. From that direction the power will flow. Now here in this case, as delta 1 is greater than delta 2, the flow of the power will from generator 1 to generator 2. So therefore G1 will be a generator and G2 here, G2 it will act as a what? It will act as a motor, that is it will absorb the power. So from the diagram, can I write it like this? Can I say PE2 will be equal to minus PE1? Yes, this is your equation number 3. Because now this generator, where is it? This generator, it is providing the power and it will accepting the power. So direction of the power PE1 is from G1 to G2. Direction of the flow of a power PE2 will be from G2 to G1. So here we will write it like this. PE2 will be equal to what? Minus of PE1. This is your PE1. Okay. Now what I will do? I will write it as multiply your equation number 1. This is your equation number 1 by M1 and multiply equation number 2 by M2 in order to calculate the equivalent. So what you will get if I multiply equation number 1 by M2, then how you will find it out? M1 d square delta 1 upon dt square will be equal to PM1 minus PE1. To the both sides we are multiplying it by M2. So treat this as an equation number 3. Now again what we have to do, not a 3, let's say I will modify the number. This will be your equation number 4 because 3 already we have given to this equation. And to this equation number 2, if I multiply with M1, then what you will get? M2 d square delta 2 upon dt square will be equal to PM2 minus PE2. So I will multiply to the both sides by M2 to equation 4 or equation number 1, and I have multiplied by M1 to the both sides to equation number 2. So treat this as a equation number 5. Now what I will do? Subtract. I will write it here. Subtract equation number you can say 5 from 4. Subtract equation number 5 from 4. So what you will get if I subtract it? What you will get? So I will now solve this expression as, now this will be your M1. This is, if you multiply this M2, you will get M1 M2. Okay, then d square upon dt square. Now here if you subtract left hand side, you will get what? D square delta 1 upon dt square minus d square delta 2 upon dt square. So can I write like this? This will be your delta 1 minus delta 2. Yes, I can write it like this. Now what is to be there on right hand side? I will write it as this pm1 into m2 minus pe1 into m2, and I am going to subtract. The equation 5 from 4. So minus pm2 into m1 minus pe2 into m1. So if I rearrange, how I will get the equation? I get it as pm1 into m2 minus pm2 into m1. Now what I have done? I have recollected the terms of mechanical power, and if I take minus sign common, then what I will get? Now here, you know, in equation number 3 already we discussed, pe2 will be equal to what? Minus pe1. So I will put it here. What is your pe2? pe2 will be equal to minus pe1. So this pe1 and this pe1, can I take common? So I will take minus common. You will get it as a pe1. And what is your answer here? It is m1 plus m2. Why you will get this expression? Because pe2 will be equal to minus pe1. This will be equal to what? This will be equal to minus pe1. So pe2 equal to put minus pe1. So minus minus becomes plus. So it will be plus pe1. And if you take a minus sign common here, then what you will get? m1 plus m2. Now what I will do? Divide both sides. Divide both sides by m1 plus m2. So how you will get the expression? How you will get expression? You will get it as m1 m2 upon m1 plus m2 d square delta upon dt square will be equal to what? Now this is the term pm1 into m2 minus pm2 into m1 whole divided by m1 plus m2 minus pe1. You will get this expression. So what this term, whatever term here we have shown to the left hand side, this is nothing but what? This will be your m equivalent. But you know that what is the formula of m equivalent? M equivalent equal to G into H equivalent upon pi f. So how I can write a formula for H equivalent? I can write a formula it like this. H equivalent will be equal to what? H equivalent will be equal to M equivalent into pi f upon G. So this is the formula of H equivalent when two machines are swinging non-coherently. So this is the derivation of swing equation when we have a two machine system or multi-machine system. Here instead of multi-machine we can say two machine system. So what happens if both the machines will be coherently swinging and if both the machines are swinging non-coherently? This is the derivation. Thank you for watching this video.